In this segment, I'm going to continue talking about polynomial functions and getting some sketches of them. But before we do that, I want to look at one theorem that's also helpful to us. And it says that if p of x is a polynomial function of degree n, and remember the degree here is just the exponent on the, or the highest exponent in our function, then the graph has at most n real zeros. Okay, and the real zeros again are the x-intercepts that we'll see on our graph, and at most n minus 1 turning points. So if I have a degree 5 polynomial, it could have 5 zeros or x-intercepts, and it could turn 4 times in order to get those. Doesn't mean I have that many, it just means I could have up to that many. Now before we do some sketching, just to review, what are our steps? What are we going to do to get this quick sketch? We're going to look first at the leading term test, and the leading term is the term that has the highest exponent, and that's going to help us determine the end behavior, what happens over here far on the right side and way over here on the left side. Then we're going to factor, if necessary, to find our zeros. And once again, the zeros, as long as they're real numbers, are going to be where we see our x-intercepts. We're noting the multiplicity, which was the exponent on the factor. If that exponent on the factor is odd, that meant we're going to cross at that x-intercept. If it's even, we're going to touch and turn around at that x-intercept. Then we're going to evaluate f of 0 because that's going to give us our y-intercept. It just makes a little bit nicer looking graph. And if desired, if we want it to get even prettier, we can evaluate f of x at test points between the zeros to kind of tell us, how high or how low it's getting as it's turning through there. All right, let's take a look at an example. We want to just get a rough graph of the following functions. Okay, so this one, it's not in factored form for me, negative x cubed minus 2x squared. First thing I want to look at, end behavior. So the highest degree term is this first one. It's negative, so that means my right side has to go down. Then I look at the exponent, that's odd, and because that's odd, that means my sides go opposite. So the right side goes down, the left side is going to be going up. Now, in order to get my zeros in multiplicity, we actually have to factor this. So looking at this, the only thing I can really do is factor out something common, and I'm going to go ahead and factor out the negative x squared. Then that's going to leave me with an x plus 2, right? Because negative divided by negative makes that a positive 2. So my factor is x, and my other factor is x plus 2. So my zeros are 0 and negative 2, and then I am going to have a multiplicity on the first one of 2 because that's the exponent on my x, and a multiplicity of 1 on the other one because there's not anything written, so we always know that's a 1. Even multiplicity is where we touch and turn, and an odd multiplicity is going to be where we cross. And then my y-intercept. Okay, so the y-intercept means you plug in a 0 for your x and work it out. Well, that's 0 minus 0 is going to be 0, so 0, 0. So we start up here, we know we're going to have to cross through at negative 2, we're going to touch and turn at 0, and then go back down to get our answer. Here we've got another example that we want to get a sketch of. So in this one, we look at our leading term, and it's a positive, so the right side's going to go up, and the exponent on it's an even number, so that means both sides are going up. If I want the zeros, I'm going to have to take this thing and I'm going to factor it. Well, first thing you notice is that they all have at least an x squared, so factor that common factor out. Then we've got a nice quadratic in here that factors very nicely as x minus 3 and x minus 1. So once it's all factored, we write down in our table our factors. Then from each factor, we ask what makes that 0. That gives me my zeros. And then my multiplicity, I look back up here, there was an exponent of 2 with the x, and 1 on the other 2. So on this one, when I have a 0 of 0, I'm going to touch and turn. And on the other 2, I have multiplicities of 1. That's an odd number, so that means we're going to be crossing at those points. So at 0, we're touching and turning. At the 3 and the 1, we're going to be crossing through. The y-intercept, it's not very interesting, this one either, because when you put 0 in here, of course, it all becomes 0. So we know we have to start way up here, come down and touch and turn at 0, go quick turn back around, cross through at 1, come back, cross through at 3, and then continue up forever.